Hi everybody, welcome to the third video. This is going to be regarding the ACLs and services that basically take a look at how to allow traffic through the firewall and through the firewall. That's something that is misunderstood in a lot of the forums that I've looked at in terms of the difference between to traffic and through traffic, and that's what this particular video is all about. So let's take a look at through traffic first. We already have established the fact that traffic from high to low, which is inside to outside, it's allowed by default. Default behavior is allowed. But the inspection is only done for what? TCP UDP traffic. But we also established that traffic from low towards high, the default behavior is to block. Now, if I want to allow that traffic, I can do an explicit ACL on the firewall. Assuming that you already know the ACL on the router, let's go ahead and take a look at how a firewall allows traffic. So firewall ACLs. The default ACL, when you create an ACL on the firewall ACLs are extended ACLs by default. They are numbered ACLs. Sorry, they're named ACLs. Or I should say named extended ACLs. So just in case you were wondering what that meant, is on a router, ACLs 1 through 99 are standard ACLs that just check the source IP address. Extended ACLs allow you the ability to check source IPs, destination IPs, source port, destination port, protocols, certain packet types. The ACLs on your firewall are extended ACLs by default. All right, so they have the ability to check source, destination, port numbers, protocol numbers, all that. Okay, so they're named extended ACLs by default. The other thing that I also want you guys to see as a difference, the ACLs on the routers use an inverse mask for matching. What that basically means, on a router ACL, 0 equals a match and 1 means ignore. Okay, ACLs on the firewall use a normal mask for matching. What do I mean by that? 1 equals a match, 0 equals an ignore. So if I had to write a router ACL to allow a particular network to come in, let's say I wanted to allow 101 permit telnet traffic from a particular network. So let's say TCP 192.1.20.0. This network, to allow anybody on this network to come in, I would put my ACL as 000.255. That means the first 3 octets will be matched, the last one would be ignored. I'm just checking the network portion. To any or to host EQ23. I'll also want you guys to take a look at 101, which is the number that tells it it's an extended ACL. On a firewall ACL, if I had to do the same thing, first of all, the ACL would be a name. Even 1 would be okay. Let's call it the outside ACL. So give it a name. Permit TCP 192.20.0. I wouldn't put the 000.255 mask. I would put the normal network mask that I would have. The rest is the same. Good so far? So I just wanted to compare how a router ACL would look to do a certain block and how the firewall ACL would look to do a block. So the difference is firewall ACLs are extended ACLs by default. They're named extended ACLs. So this is a name and it automatically implies it's an extended ACL. On the router, you use a inverse mask for matching. On a firewall, you use a normal mask for matching. So basically says anyone on this network should be able to come in and do a telnet. This is a very open ACL, but I want you guys to see an example of that. Now, let's do some configuration tasks over here so you guys understand that as well. What my objective over here, my first requirement is allow the following traffic coming in from the outside, coming in into the outside interface. What traffic? Number one, I want to allow 192.1.20.0 network to telnet and ping the 10.11.11.0/24 network. All right, number two, allow anyone on the outside to access a host 192.168.3.11 on the DMZ network for web and HTTPS traffic. Allow anyone on the outside to access a host 192.168.3.12 on the DMZ4 network, or sorry, DMZ3 network for, let's say, DNS traffic. Okay. That's my first requirement to put the ACL in. How would I do this ACL? Access-list, we'll call it outside. That's just a name. I generally try to keep it the name that matches the interface that I'm going to apply this ACL on, just to keep it simple. So access-list outside, permit, my first requirement is to allow telnet and ping from 192.1.20.0 to 10.11.11.0. So I'll say TCP 192.20.0, 255.255.255.0 to 10.11.11.0, 255.255.255.0. And then I also want ping to work on that. So in the same ACL, I'll allow ICMP 20.0, same network, same destination. The ping is an echo packet. So I'll say echo. That means allow echo to come in from where? 20.0, or that means anyone on the 20 network should be able to ping anyone on the 10.11 network. This should be 0. And the third one, or the second one over here, is allow anyone on the outside to access 192.168.3.11. So this ACL, again, I'm going to do it on the outside because that's where the packet is coming in from. Permit TCP any as a source destination. I'm going to use a keyword host 3.11, EQ for 80, and for 443, which is HTTPS. So I'll change the port number over here. That takes care of number 2. Third requirement, outside, I don't have these servers, so these are hypothetical. So DNS traffic is UDP. Anyone on the outside should be able to access 3.12, EQ53, that's the DNS traffic. So create the ACL, creating the ACL. So that's how you create the ACL. I'm going to take this, copy it, go to my ASA over here, and paste it. You can check the ACL by doing show run access dash list. That shows you the running config of the ACL. If you want to check the ACL and the hit count, show access dash list is the command for that. Right now, there's no hit count because no traffic has been initiated at this point. Now, although I created the ACL, just like on a router, I need to apply it. How do I apply this ACL? Applying the ACL. Applying of the ACL is done on the interface. On the router, you would have done this interface E0/0, for example, and then inside the ACL, inside the interface, I would say access dash group, whatever the name or number is, let's say 101 in. So on the E00 interface, on the inbound, apply this ACL content of 101. On the firewall, it's done a little different. It's done globally. The command is access dash group, followed by the name of the ACL, which is outside, uppercase. This needs to match. This is case sensitive, the name of the ACL, followed by the direction. Which direction is this ACL going to be applied and what interface is it going to be applied to? So let me write the syntax first. So the command is access dash group, the name of the ACL, followed by the direction, in or out, whatever direction you want to apply the ACL on, the keyword interface, and the interface name. So in this case, the interface in is the direction, inbound, interface outside. Now notice I put outside all lowercase over here, although the name of the interface is outside O capital. But as I told you earlier on in my first video, that actual command. So as I told you in the first video, the name is not case sensitive, but it preserves the case. So I'm going to use outside lowercase, and I want you guys to take a look. It does take the command, even though my name of the interface is outside uppercase. You can check that by doing show name if. You'll see that the name of the interface is outside with O capital, right? But I applied it using the O lowercase over here. Although I did that, in my running config, it would have converted it over to preserve the case. I do show run access dash group. You will notice that it has changed the O back to uppercase. So that way it preserves the case. So it has applied the ACL. Out of these ACL entries that you have, the only one that I can use is a ping and the two top ones. The bottom three are hypothetical servers that I have. Okay. Actually, I'll also add another list or list entry over here, so we can test that as well. My fourth capability, allow anyone on the outside to ping R3 E00 interface. So basically, I also want to allow this other entry, access dash list, outside permit ICMP any to host 3.3 echo. We'll put this line as well in there. So I have one extra line of ACL that should have been added over here. And if you take a look at show access dash list, it'll show me the ACL with the hit count of 0. Now we'll try to initiate some traffic from the outside to see if it works. So to test it, I'll do 3 flows. Number 1, from this guy, I'll telnet to 10.11.11.1, which is this guy. So that traffic is allowed on the ACL over here. That should be allowed to come in. Although I'm coming from a low interface to a high interface, I'm going to ping it to test the ping capability. And then I'm going to also ping R3. Just to show you it's only for ping, I'll try to telnet into R3 and that should be blocked. So let's try these 3 things. First of all, I'll go to router 2, the outside router, telnet to 10.11.11.1, which was not working before because the ACL was not there. Now it is working. Not only that, if I try to ping it, that should also work because I allowed it. If I try to ping 192.168.3.3, that should also work. Okay, but if I try to telnet to 192.168.3.3, that will not work because my ACL is not allowing it. Good so far, guys. So this should show you how an ACL is written to control the traffic flow. So I wrote an ACL over here to control traffic from where? Outside to the DMZ and outside to the inside interface. So I write the ACL. The purpose of the ACL over here is to control traffic that is going through the firewall. Now that's where the difference comes in between a router and a ASA. The function of the ACL on a router is to block traffic coming into that interface, whether it's destined to the interface or it's destined through the router. This is where an ACL differs on a firewall. The ACL on the firewall only controls through traffic. Through traffic means traffic going through the firewall, not destined to the firewall. Not destined to the firewall. Let me show you that. In my ACL over here, if you take a look at it, what ICMP traffic am I allowing on the outside? I'm allowing 20.0 to ping 10.11.11.0. I'm allowing this entry over here. I'm allowing ICMP any host to ping 192.168.3.3. Can I ping from the outside the firewall itself? You know that an ACL has an implicit deny any. So anything that's allowed in the firewall is permitted. Whatever is not specified, implicit deny any. All right. Now, so if that's the case, if I sit on router 2 and I try to ping 192.1.20.10, implicit deny should take care of it. But that's not the case because that traffic is not through traffic. That is called the to traffic, destined to the firewall. So you need to understand that the ACL only controls what? Through traffic. It has no bearing on the to traffic. So if I go and try to ping from R2 the firewall, which is 192.20.10, that is not through traffic. I'm hitting the firewall, the same side interface. So I can ping it. That should not work based on the ACL. It does because the ACL has no control over to traffic. So the question then is, how do I control to traffic? Well, to traffic, most of the traffic is blocked because no services per se are running on the firewall itself. So let me explain that as well over here. To traffic. To traffic is what traffic? Traffic destined to the firewall interface. Not going through it, but it's going through the firewall. Okay? What about this traffic? Let's do a write-up on that. To traffic is controlled by the service running on the firewall. By default, the only service that is running on the firewall is the ICMP service. No other traffic is allowed to the firewall. Okay? If you try to HTTP into the firewall, telnet into the firewall, SSH into the firewall, all that is blocked. The only traffic that's allowed to the firewall is ICMP. That's why you are able to ping that interface on the outside, or for that matter, inside or the DMZs. So if I go over here, I should be able to, even from R1, be able to ping my side of the interface, 10.11.11.10. R3 should be able to ping 192.168.3.10. So everyone can hit the firewall. The reason again for that is that the true firewall is controlled by the service. Did I write that? No other traffic is allowed to the firewall. The only service that's running is ICMP. Enabling or disabling of a service on the firewall is a per interface characteristic. So I can control what protocols, if I want to enable, they're enabled for which interface. Or if I'm disabling, the only one that I'm disabling by default is ICMP, which interface am I disabling it on? Okay. So let's say I don't want my outside interface to be pinged by the outside interface. So how, or people on the outside. How do I do it? As I said, the default characteristic of ICMP is it's enabled, but that's the only service that's enabled. No other service is enabled except for ICMP on all your interfaces. That's why you can ping any of the interfaces, not because of an ACL. Even if I put a deny IP any ACL, I'll still be able to ping the firewall interface. Let me just do it and then I'll take it off. I'll do it on the inside interface. So I'll create an ACL over here. Let's call it deny. I'll say deny IP any ambiguous. Oh yeah, no, that should be okay. Deny is probably a bad word. My ACL deny IP any, and now I'm going to apply it. Access dash group my ACL in interface inside. So I applied it to my inside interface. Now what's going to happen is if I go over here, I will still be able to ping it, although I have that ACL applied, because that does not control traffic to the firewall, it's through the firewall. You get my point? So now I will not be able to do this. Remember, I was able to ping, oh, this is not it. I was able to ping or telnet to what? 20.2. I now cannot do it because that's through traffic that is blocked by my interface ACL, the deny IP any. So I just want you guys to see, although I put the ACL over here, it has no effect on the to traffic. I can still ping the inside interface. So let's take this ACL off. No access dash group, take it off. No access dash list, my ACL in interface, or my ACL list. Deny IP. So show run access list should only leave me with one ACL, the outside ACL. So how do I control it then? Let's take a look at the controlling of the ICMP now. Enabling a service or disabling a service is on a per interface basis. My requirement now. No one should be able to ping the outside interface of a firewall. Okay? At the same time, the ASA should be able to ping the outside networks. So let me explain this to you. First of all, if I want to block people from pinging the outside interface, I could do ICMP. That's a command. That's a service that I was talking about. You do it based on the service. The service for ping is ICMP. I'm going to say deny. I want to deny the service for any source coming into what? The outside interface. ICMP deny any outside. So when I do that, I have actually now blocked the to traffic. This only applies, the service only applies to traffic. What do I mean by that? It has no effect of through traffic. So if I had an ACL allowing traffic going through the firewall, that would still be working. So let's do this over here. First, I want to see if my ping is working on the outside. It is. So now I'll say ICMP deny any outside. So I blocked any ICMP to the outside interface. So router 2 now on the outside can not ping 20.10 because I've denied it. That's through traffic. That's controlled by the service itself, not by the ACL. At the same time, if it's any through traffic, that means if I wanted to ping 192.168.3.3, which is allowed by this through ACL, come on, which is allowed by this through ACL, right over here, this entry, that'll still work because the ICMP command does not affect through traffic. It is only for through traffic. But what it also did for me is it also blocked the ASA from pinging anybody, because when I send the ping out, that's not a problem. When I say ping, let's say 192.1.20.2, this interface, the ping will go out. That's an ICMP echo. The return traffic, because I have specified to deny any what? ICMP on the outside interface. As I said, it's per interface. It's going to block my echo reply as well. So if I'm blocking one, I'm going to block everything now if I put this line in, because what you don't see over here is the implicit deny any. So that's blocking everything else. Good so far? So now what if I want echo to allow echo reply to come back in and deny the rest? Rather than doing the deny any outside, what I would do is this. I'll get rid of this command. Oops. So I'll say no ICMP deny any. Now this guy should be able to ping me. Good. What I want to do is I want my guy to be able to ping this guy 20.2, but I don't want anybody pinging me. So the way I would do that is do this: ICMP permit any echo dash reply. So only allow echo reply on the outside. When I put one line in here, the implicit line that you don't see over here is what? ICMP deny any outside. So it's only allowing what? Just like an ACL, if you have nothing in the ACL, everything is allowed. But if you put one line in, it denies the rest. So ICMP deny any outside is automatically put in. So when I'm permitting any echo reply, so the only one that's the only traffic that I'm allowing is the echo reply. So I can ping 20.2, the return traffic is echo reply, which is allowed. So my packet going out is an echo packet. Outbound, no problems. Outbound is the echo packet. But the control is on the inbound. This ICMP service is always for return traffic or incoming traffic. I'm basically specifying allow echo request on the outside interface. So that's going to be allowed onto the firewall. So that traffic is allowed on the outside firewall, but now the rest of it is blocked. So if I go to router 2 and try to ping 20.10, that's blocked. So what I've accomplished is I've blocked a particular service to the firewall. This has no relevance for through traffic. The through traffic is controlled by the ACL. So what you need to understand over here is that as a, what do you call it? As the final thing for this particular video is that if you want to control through traffic, it's controlled by using an ACL. If you want to control through traffic, any service running on the firewall is done by the service. So for example, later on when we do the management of the firewall, we want to allow telnet to the firewall. Telnet to the firewall is controlled by the service because it's through traffic. So we will need to enable telnet to the firewall, or SSH to the firewall, or HTTP to the firewall. All these services by default are blocked. The only service that allows you to do any type of packet to the firewall is ICMP. So to do this, I didn't do this one. What did I do instead? I said ICMP permit any echo reply to the outside interface. As I said, it's per interface, so it will not apply to the inside. Inside, everything is working. It's just the outside that I'm doing this on. So if you want to do this on the inside or the DMZ, you would do it on a per interface basis. So to recap, the main objective of this particular lab, review, two main things that you learned over here was to control traffic through the firewall. You use the ACL. The ACL does not affect through traffic to the firewall. To control traffic to the firewall, you need to use the service. The only service that is enabled by default is the ICMP service to the firewall. Hope this video was useful to you guys. Oh, one more thing I had to do is the same security level interface. We'll do that as a separate, video just for same security traffic. That would be the next video. All right, so this particular video was focused on normal ACL from low to high, how to allow the traffic, and how to control to traffic. Hope you enjoyed it. See you on the next video. The next video is going to be how to allow traffic from same security level to same security level. Thank you guys. Thanks for joining. See you on